I hope everyone is doing good. So how are your preparations for the exams going on? I know that just 34 days are waiting for you, right? Just 34 days. And I also know that you guys are doing very hard work and don't worry at all, because you're going to get marks more than what you expect, because hard works will always be paid. Okay, so I know that for so many my face will be new. For them, myself Ameer Sir, master teacher of JEE Physics at Vedantu, and you can call me Ameer for anything and everything. I'll be there for you. Okay, so guys, you are Ameer Sir. Yes, yes, you are correct. Okay, you know my full name. That's good. Okay, Pawan, I took your name. Okay, good. Okay, Pawan, I took your name. Don't worry. Okay. Now, I hope you guys might be knowing why we are here, okay, gathering around. So we are here as a part of CBSE Sprint, where we're discussing maximum number of previous year questions, okay, in a chapter-wise manner, and we'll also take the theory also along with it, and we'll make that particular topic so awesome. We have completed 2-3 topics already. I hope you guys might be knowing about it. And today we are going to discuss one of the important topic, which is also beautiful at the same time, which is about the capacitance or the capacitors. Okay, and you have to know that this is not only important for your board exam, it has very much important for your JEE and the NEET level exams. We'll do all the things. Okay, I'll make you understand the theory. First I'll start with some theory, then we'll be going forward, so don't worry anything up at all. Okay guys. Okay, no, we are not doing Mendy at this time. Okay guys, so yeah, let's start. Pratiksha, hi, you are there. Good afternoon. Okay, we are going to start now. 1 minute. There was some technical issue because this thing is not moving, the slide is not changing. Give me 1 second, not 1 second though, give me 1 minute. Okay, so before we start, let me know how are you doing your preparations. Weightage for teaching. Good afternoon Priyanshu, IIT topper. Good afternoon everyone. Okay, so instead of that, let me use the keyboard over here. This thing is not working. So these are the list of derivations, guys. These are the list of derivation. What you can see on the screen is a list of derivation that you must study before going to the board exam. So I suggest everyone to take a photograph or the screenshot of this. It will be so much better for you. Okay, so I'm not married, Aman. Okay, you don't have to think about it. Don't worry, my parents will take care of that. Okay, so I hope you have taken the screenshot of it. So the second page, please take the screenshot, those who want, those who wish, it'll be good for you guys. Okay, then these are the topics. So these are the topics which you can see. These ray optics, wave optics, electrostatic 2 classes I have already completed. Now what we are having on today's class is capacitance. Okay, and tomorrow and day after, as a chapter current electricity is too much important, we'll be going with that, and you can note down the date. It is on 29th and 31st. Then we'll be having moving charges and magnetism. This is the schedule for this week. Okay, so then those who want it for the next week also, you can take a screenshot. I'm just giving you the schedule just because I want every one of you be there at the right time at 1 o'clock. Okay, so we can chat a lot and we can do many questions at that particular time. I hope you got the timetable right. Please take a screenshot. Be there at 1 o'clock every afternoon at the given dates. Fine, all good. So those who have already seen my lectures, so many of you might have liked it, isn't it? I hope the class was awesome. So for those people, I have to tell you, don't forget to like the videos, whatever it was done previously and whatever you're going to watch now. Then share it if you like it with your friends and subscribe it. Fine, all good. So let us start. So shall we start? Because we have done enough talking, we don't have time to waste again. So shall we start? Give me a yes or a thumbs up so that we can start now. Okay, thank you so much, Pratiksha. Okay, all good. Okay, yes. So let's start. So we are going to talk about the capacitors. So you guys know what is capacitors. Capacitors are devices which are there to store the charges. So we have to store the charges in it. So mainly we are going to discuss in this chapter, we are only concerned with the parallel plate capacitors, which means we'll be having two plates. 1 minute. Okay, so we'll be having two plates like this which will be parallel to each other, and whenever we connect it across an external potential, what will happen? The charges will start getting stored in it. How will this happen? Because whenever you apply a potential difference between these parallel plates, here as it is having a positive potential, the electrons will start flowing in this particular direction. The electrons will start flowing. Okay, I'll write it separately. It is not the direction of the current, it is the direction of the electrons. So the electrons will start flowing away from here and it will be moving towards this particular plate. If I can talk about, I can mark it as plate 1 and plate 2. So the electrons will move from the plate 1 to plate 2, which will give a positive charges to this particular plate and the negative charges to this particular plate, which means, as you can see, if I'm applying the potential more and more, the charges that is applied on this particular capacitor keeps on increasing, which says Q is equal to Q, which is the charge developed on this capacitor plate, is what you can say that Q is directly proportional to V. So once you convert this into equality, you can have it is equal to KV, or you can write it as C into V. So this is the basic equation related with what? Related with the capacitor plates. Yes or no? Hindi, Ujjwal. So those who know me might be knowing that I'm from Kerala. I'm very bad in Hindi. So sorry guys, I can't talk in Hindi. Fine. Okay. So many of you might be having a doubt how to make a derivation for the capacitance of a parallel plate capacitors. Right? So what is this capacitance first? Capacitance is an amount which shows how much of charge can be stored in the charges can be stored in this particular plates. Okay, if the C is more, the charges will be more. So don't worry, we'll be taking the 1 more questions. Fine. Okay, all good. So first let us discuss the theory. We'll start with the theories, and after the theories we'll be going one by one. Okay, so you don't have to worry at all. If you're having any doubts, you can ask me. I'll be replying at the moment. So for the derivation for the capacitance of the plates, you know that here just by rearranging this equation, C will be equal to Q divided by V, where V is the potential difference between the plates. So if V is there, potential, which means the electric field is there, and distance between the plate is given, how will you make it as an equation? You might be already knowing from the chapter, right? V is equal to E into D, where E is what? The electric field between the plates, and D is the distance between the plates. And I hope you might be knowing one more thing. For the parallel plates, or the plates, or in between the parallel plates, the electric field produced is given by how much? It is equal to sigma by epsilon 0, right? So sigma by epsilon 0 into D will be giving you the potential. Yes or no? Yes. So what I'm going to do is I'm going to substitute for this V in the equation for capacitance. So how will it be going? So capacitance C is equal to Q divided by V is equal to sigma by epsilon 0 into D. Yes or no? Say yes or no? Guys, okay, very good. Pratiksha is there to give the answer for everything. So Q divided by, who will tell me what is sigma? Yes, I am a Mallu. Okay, so who will tell me what is the sigma? What is the sigma? Tell me fast. We don't have much time to waste over here because we have many questions waiting for us, and it's going to be so awesome. Yes, charge density, which is how will you make it as an equation? Charge density is equal to charge divided by area, which means Q by A. So sigma, I'm going to write it as Q divided by A. Epsilon 0 is already there, and D. So Q will cancel and it goes up. So you'll have the net equation as A epsilon 0 by D as the capacitance for the plates. Okay, it is epsilon 0, which is permittivity of the air, because in between the plates you have the air, and if it is not air, if it is some other dielectric constant, or it is some other medium, you can put the permittivity of that particular material over there. All good? Any doubts? Anyone in the derivation? Because this is really important derivations. Any doubt, anyone? Guys, I don't want a sleeping class in this very fine afternoon. I want everyone to be in their maximum energy, and the chat should be so flooded with the answers. Okay, so many were asking about the 1 mark question also. You don't have to worry about it. We'll be doing it. Okay, so don't worry. I'll take care of everything, each and everything to make you on the top of this particular exams. How to apply for numerical? We'll do, no doubts, right? Okay, one more time, there is no this is very simple. What I have done is we have done Q is equal to CV, which was a basic equation, then C is equal to Q by V, then have applied the formula for potential, which is equal to electric field into the distance between them and all those things. Okay, so I'm going to move on, guys. So let's get to the next slide, which will be the next question for us. 1 minute. Okay, so we have the first question in front of us. What does it say? A parallel plate, I'll read it for you. A parallel plate capacitor of capacitance 90 picofarad is connected to a battery of EMF 20 volt. Fine. Okay. If a dielectric constant K is equal to 5 by 3 is inserted between the plates, the magnitude of induced charge. They are asking the magnitude of the induced charge not on the plates of the capacitor, but where? Do you know where we have to find out? It is the charge induced on the dielectric. Dielectric is what they are asking, right? So we should be having a lot many knowledges if you want to solve this particular question. I hope every one of you guys are ready to listen to the theory and do the questions after me, right? Yes or no? Okay, those who know the answer, it is good. We'll discuss about the answer. Before that, let me give you some lecture about it. So are you all ready? Yes? Okay, very good. So let me take a fresh page and let's start the derivation one by one. Okay, so we have the capacitor plates. So if we have the capacitor plates, you know that the capacitance value is equal to A epsilon 0 divided by D if it was air. Yes or no? Now we are going to change that particular air into some other medium. So in that particular case, the capacitance will obviously change. How much it will be? A into the permittivity of that particular medium, that is epsilon divided by D. So C dash is equal to A epsilon 0 epsilon by D, and I hope everyone might be knowing how to replace this epsilon with the dielectric constant, because epsilon is given by K epsilon 0 divided by D, which is equal to K times A epsilon 0 by D is equal to C. So C dash, we got it as what? C dash is equal to Kc. Understood till here? So we got C dash, the new capacitance is equal to K times the capacitance in the previous case. Okay, now let us see what is happening whenever you are keeping a dielectric material in between. To what? In the charge distribution. Okay, now whenever you are having only the air in between the capacitor plates, the electric field in between them is given by sigma by epsilon 0, because it was air. Okay, don't worry, once I start explaining this particular theory, you will slowly understand the questions. Fine. Okay, so electric field is given by sigma by epsilon 0. In which direction? In which direction? From positive to the negative plates, right? Okay, this is what happens. So whenever you keep a dielectric material, which means an insulator in between them, so I'm keeping an insulator in between them. Okay, an insulator may consist of polar molecules or non-polar molecules. I hope you might be having a good knowledge about polar and non-polar molecules. So in the presence of an external electric field which is existing between the plates, the polarity or the polar molecules on the non-polar molecules will be aligned in the direction of the electric field. So the polar molecules will be aligning in this particular direction with negative and positive, just like this. Okay, because of the presence of the external field, which will give this plate a net positive charge over here and net negative charge over here. Okay, this is a charge absorbed or available to this plates or the dielectric constant in between the plates. Fine. So because of the charge density which is on either side of this particular material, an extra electric field will be produced between them in the opposite direction. Okay, so because of that, the net electric field will be decreasing in between the capacitor plates. Okay, so what will happen? What will be the current value of electric field? Obviously it will be decreasing, so that will be equal to sigma by, instead of epsilon 0, it will be equal to K times epsilon 0. So the new electric field will be equal to sigma divided by K epsilon 0, because it is the new material. So from the equation itself, it is clear that the electric field has decreased. Yes or no? So you got it? Don't worry. You will get it once the explanation is over. Okay. So the electric field has decreased because of what reason? Because of the extra electric field which is developed inside this dielectric constant in the opposite direction. So what can you write? The net electric field which is available now, which is sigma by K epsilon 0, is because of what? The whatever was the electric field in the first case, which was sigma by epsilon 0, from that I have to subtract the electric field produced because of this what? Because of the dielectric in the opposite direction. How will I write it? That is equal to the new charge density, which is sigma dash divided by epsilon 0. So E net we already have, sigma by K epsilon 0 is equal to sigma by epsilon 0 minus sigma dash by epsilon 0. Yes or no? Okay, so sigma dash I am taking it to opposite side. So sigma dash by epsilon 0 is equal to sigma by epsilon 0 minus sigma by K epsilon 0. Yes or no? So sigma is equal to what? Q divided by A. So I am going to write it as Q divided by A, Q divided by A, and Q dash divided by A, because we have sigma dash over here. Yes, so this will be Q dash will be equal to Q minus Q divided by K, or which is equal to Q into 1 minus 1 by K. So the charge which is developed on this dielectric is equal to the whatever the charge on the capacitor plates into 1 minus 1 by K. This is what you have to do it. Understood till here, guys? Guys, I'm asking, you guys understood till here with the derivation? Yes? So this is the value, this is the equation you have to use in order to find out the charge which is on the dielectric, not on the plates. Got it? Yep. Okay. Okay, now we have to calculate the values one by one. So in order to find this Q dash, we should be having the charge Q, right? So we should be having this charge Q on the plates. So we'll also be doing NCERT also, we'll be doing everything, don't worry at all. So first we have to find out the charge on the plates. So how will you do that? I'm going to clear it out. I'm going to clear whatever it is there on the board. Okay, and I'm going to write the equation whatever we have solved now. So what we have solved, Q dash is equal to Q into 1 minus 1 by K. Yes or no? Yes. So I have to find out this particular Q. Q is equal to, what is the formula? Q is equal to C dash into V. Why C dash? Because we are talking about the new capacitance, right? And we have already proved that C dash is equal to K into C into V, right? So what is this K, C and V? So we'll be doing it from the previous case, right? Okay, so what is the value for K, which is equal to 5 by 3? I'm going to substitute over here. So it is 5 by 3 into capacitance value is equal to 90 into 10 power minus 12, and the voltage that is being applied is 20, right? So once you do this, what do you have to get? What you will be getting? So what you will be getting will be equal to 3 nanocoulomb. So the charge Q will be equal to 3 nanocoulomb once you do the particular calculation. Then you have to apply that particular Q, whatever is that Q in this particular formula. Q dash is equal to Q into 1 minus 1 by K. So that is 3 into 1 minus 1 by K. Fine. K is equal to 3 by 5, and you will be having the net charge is equal to 1.2 nanocoulomb. Done, guys? So we are doing this higher level questions. Do you know why we are doing all these higher level questions? So that you will be thorough with all the higher level theories which will make you the simple problems do in such a manner. Okay, you'll be doing all the simple problems once you're clear with all these theories very simply. Within seconds you will be able to do it. Fine. So that's why we are making you do the bigger problems and the higher level problems, so that all your theories will be much concrete. Done? Okay, all good. Shall we move on? We'll be doing Kumar. Fine, don't worry at all. So shall we move to the next question? Srishti Rao, what were you telling? I couldn't read it. Physics. Okay, what is your doubt? Okay, we are moving forward. Guys, so many are telling. So we have the next question waiting for us. Fine. So the question is, okay, so a parallel plate capacitor. So okay, next question you have. Those who want to do by themselves can do and give me the answer. Those who want to listen, please listen to me. I'll be making this particular question very clear to you. So the question goes like this: a parallel plate capacitor is made of two circular plates. Okay, the parallel plates are of circular in shape, that's all, and separated by a distance of 5 mm. So that D value is given with a dielectric constant of 2.2 between them. When the electric field in the dielectric field is given as 3 into 10 power volt per meter, the charge density of the positive plates will be close to. So they are asking the charge density. So what is this charge density? It is sigma. So what is given? The electric field in the dielectric field is given. Okay, so what is the equation for that? You know that the equation is equal to what? The electric field will be equal to sigma divided by K epsilon 0. So I hope you remember, this was the theory which was discussing in the previous question also. So the electric field in between the plates, if a dielectric is kept, is given by sigma divided by K epsilon 0, right? Yes or no? Yes. So we want to find out the sigma only. Yes. So how will you find out the sigma? Sigma is equal to electric field into K into epsilon 0. What is the value for electric field? It is 3 into 10 power 4 into K value is given as how much? It is given as 2.2, and I hope everyone might be knowing what is the value for epsilon 0. Who will be giving me the value for epsilon 0? Who is there? Guys, give me the value for epsilon 0 very fast and quick. (8.85) into, very good Devanta, 8.85 into 10 power minus 12. So this will be the value. So once you do the calculation, what will you be getting? What will be the answer that you will be getting? 10 power 4 and 10 power minus 12 is 10 power minus 8. So one more 10 you will be getting, and the final answer will be how much? What will be the final answer? What you can see over there? It is 6 into 10 power minus 7. Very simple question, right? Yes or no? Yes. Okay, so V is equal to ED. Where is minus sign? Okay, the minus sign, what does it correspond to? So that's what was your doubt, right? Okay, so it is given that we have to find out the work done, right? But we are already taking the direction whenever we are doing the problem. Either you can use a minus sign in the equation and do the problem, or you can take the direction previously and do it as such. So I have, in the previous problem, I was taking the direction and doing the problem as such. So once the direction is taken, again if you apply the negative, both of the negation will be cancelled and the problem will be wrong. Okay, either you take that particular sign or you can take the direction by yourself. Fine. Negative only shows that the direction is in the opposite direction, that's all. Okay, so that's why I haven't taken separately, because I have already considered the direction in the opposite. Yes or no? Okay, why distance is given? In order to make you confused, that's all. Because that particular question, the question person whoever is making the question will be thinking that okay, that particular thing should be popping up in your mind. Okay, so you shouldn't be deviated from your path if you know the correct answer. Fine, torsion balance and all we'll be discussing whenever that particular part is being taken, don't worry. Okay, Pratiksha is there, mark and clear for her. So let's move forward. All good? Okay, so we have the next question. What is it? What is there in the question? So two capacitors are there, C1 and C2 are charged to 120 volt and 200 volt respectively. It is found that by connecting them together, the potential on each can be made 0. So what is happening? You have two capacitors, okay, one is charged with a potential of 120, the other is having 200. They are both connected. If both of them are connected, if two capacitors are connected just like that, what will be the kind of connection you will be having? What kind of connection is possible if two capacitors are connected as such by using the wire? What kind of connection will it be having? What kind of connection, guys? No? What kind of connection will it be having? No answer. It will be having, look, I'm having a capacitor, another capacitor is there. If I want to make them connected, the only way of making a connection between them is equal to parallel connection only. Look, how can I connect these two things in parallel? In series? Can anyone tell me? The only way of connecting it is in parallel. Look, this is the only way of connecting. Both of them has to be connected. I can't let one of the plates to be without making any connection. So this is the only way of connection, which means this will be in parallel connection, right? So one is with the capacitor C1 is with 120 volt and the other is C2 is with 200 volt. But it is said that the common potential after they are connected like this is what? 0. Can you tell me, if two capacitors are connected in parallel fashion, how will you find out the net value of potential? Guys, you know that? How will you do? How can we do that? How will we do? We'll be doing C1 V1 plus C2 V2 divided by C1 plus C2 is the common potential, right? And what is given? The common potential is equal to how much? 0. So once you cross multiply the denominator with it, what will you get? C1 V1 plus C2 V2 is equal to 0. Yes or no? Yes or no? So what is the value for C1? It is not given. Let us write as C1 itself. It is having a potential of 120 plus C2 into V2 is equal to how much? C2 into V2 is how much? C2 itself, and V2 is 200 is equal to 0, right? So what will you get? C1 by C2 is equal to negative of 200 divided by 120s. 0 zeros cancel, so this will be equal to 5 divided by 3 with a negative sign, right? Yes or no? So what does this minus sign corresponds to? Can anyone tell me? Negative sign, it corresponds to what? It corresponds to the positive is connected to, the positive of the cell is connected to the negative over here. That's all. Fine. The positive is connected to the negative of the cell. Okay. So if this is the kind of connection already, okay, then the change in equation is what? The change in equation at that particular moment is here already you have to put a negative sign. Okay, so if this is the kind of connection, again you have to put a negative sign, because I hope you remember this kind of, whenever the cells are connected in the opposite, positive connected to negative, you have to put a negative sign over there. So similarly, if the plates are also connected, you have to put a negative sign, so that negative and negative will make this positive. So which option you can have? Which option? 3C1 is equal to 5C2. Yes or no? Understood or what? All good? Yes, reverse polarity, that's all. All understood, guys? So happy till here? Understood all the theories till here? Yes, then it's great. So we'll be having the option B. So that's why I told you must be having a very clear-cut knowledge, else you will be going for which option? C, right? You will be going for C if your theory was not that good, right? So that's why I told, make your theory so good, because I don't want any one of you to lose your mark just like that. So let's move forward. Okay, So next question we have, it is a bit higher level problems. Let me tell you, it is a bit higher level problem. So the question is, I'll read out the question, then I'll discuss the theory. Fine? Okay. So let's see the capacitance of capacitor discharging through a resistor. So you have a capacitor and a resistor is connected across that capacitor, and if a resistor is connected across the capacitor, what will happen? The charge will be discharged, which means from the initial charge, the charge on the capacitor keeps on decreasing. Fine? Okay. Hi, VP Wizard. Very good. Welcome to the class. Then T1 is the time taken for the energy in that capacitor to reduce to half its initial value, and T2 is the time taken for the charge to reduce to 1/4 of its initial, T1 by T2. So first I have to explain the theory, then only you will be understanding it. Okay, look, listen to this particular part. I don't know how many of you are very comfortable with this theory or have already done this particular theory. So if you have a capacitor plate which was fully charged to Q, and if you connect this capacitor across the resistance, can you tell me what will happen? What will happen to the charge on this capacitor plates? What will happen to the charge on the capacitor plates? What will happen to the charge on the capacitor plates? Obviously, the charge keeps on decreasing, right? Because the charge on the capacitor, yes, very good. The charge on the capacitor will make a potential difference and the current will start to flow through the capacitor, right? So once the current starts flowing, the charge decreases, and derivation we are not doing, but I'll tell you the amount of charge which is present in the capacitor plates after a time of t is given by Q is equal to Q e raised to minus t divided by tau, where tau is the time constant given by R into C, where R is the resistance of the resistor and C is the capacitance of the resistor. So what is this? After a time of t, the amount of charge present will be equal to this. As you know, once the time increases, you know that e raised to minus value keeps on decreasing, which will decrease the present value of the charge. Q gives you the present value of the charge after a time of t, where capital Q is the initial value of the charge. Yes or no? Understood till here? Yes. Okay. Now you have to tell me what is the value for or what is the formula for. So what is the formula for what? For the energy stored in the capacitor plates. Who will tell me? Who will tell me what will be the energy stored in the capacitor plates? Energy stored in the capacitor plates is equal to Q square divided by 2C, right? Okay. Initially what will be the charge? That will be equal to capital Q square divided by 2C, right? Okay, so many formulas are there, CV square by 2, so we are using, as we are concerned with Q, we are using Q square by 2C. Okay, initially this will be. Now, after a time of t, what will happen? After a time of t, the energy will be equal to whatever the charge present at that time divided by 2C, right? Because the charge decreases, so the energy on the capacitor plates also decreases. What is the present value of the charge? It is given as Q e raised to minus t by 2 the whole square, right? At that particular moment of time, the time is becoming t1. So I am going to write it as t1 over here, because it is the energy is being described after a time of t1. So divided by 2c. Fine. So this is equal to Q square by 2c e raised to minus 2t1 divided by 2. Yes or no? Yes or no? Yes. Thank you so much. Okay. Now what they have told you, I'll take the previous slide. So it is told that after a time of t1, the energy is reduced to half. Okay. So the initial energy was Q square by 2c. After a time of t1, the energy is reduced to half, which will be equal to Q square by 2c by 2. Yes or no? So that I'm going to write it Q square by 2c by 2. Fine. So this will be cancelled, this will be cancelled off. Okay. Then what can I write? 1 by 2 is equal to e raised to minus. So I'm taking 2 up so that this negative will be cancelled from e. So what can you write? 2 is equal to e raised to 2t divided by 2, taking ln from both the sides. ln2 will be equal to 2t divided by 2, which means t1, and the t1 will be equal to 2 by 2 into ln2. This is t1. Yes or no? Yes or no? Understood? Okay, I'll show you the board. So the t1 is equal to 2 by 2 into ln2. Yes or no, guys? All good? Okay, now we have to define for t2. Okay, so let's see what was this t2 again. What was this t2? T2 is the time taken for the charge to reduce 1/4 of its initial value, right? So I'm going to rub this particular part. So Q is given by capital Q into e raised to minus t by 2. So after a time of t2, Q is becoming 1/4 of the initial value. So it is becoming 1/4, okay, after a time of t2. Yes or no? Yes or no? Yes, Q cancel. So you will have 1 by 4 is equal to e raised to minus t2 by 2. So 4 is equal to e raised to t2 by 2. Yes or no? Yes. So taking ln from both the sides, ln 4 I am going to write it as ln2 square is equal to t2 by 2, and t2 is equal to 2 into ln2 square can be written as 2 times ln2. So you got t1 value also, t2 value also. Understood till here? Now what is remaining? Just the division parts. So t1 divided by t2 will be equal to 2 ln2, 2 ln2 will be cancelled. Then what you'll be having? So t1 is 2 ln2 by 2, and t2 is equal to 2 into 2 times ln2. So both will be cancelled. What will be remaining is 1 by 4. Yes? Good. So how was the question? You guys find it awesome, because you don't have to apply only this for the board exam. Don't use it only for the board exam. It is very useful for your JEE and NEET level also, because the theory level is that high, so it will be good. Understood? Everyone? Don't worry, okay, because I'm trying to teach you. Once you are so much good in it, once your theory is so good, what you can do is it will be so much easy for you, and you will be do it in a very quick fashion. Yes? Okay, that's great. So guys, I hope you understood, okay, and I hope you might be knowing that it will be very helpful for you if you get so much of classes like this. Me and so many physics teachers are waiting for you at Vedantu, because class 12 crash course have already started, right? You'll be having the live classes. You can access to the recorded version will be there, and will be given with the assignments. Everything will be done, okay? And how much you have to pay for this? For getting all these things, you just have to pay 3,799 if you apply the code AMECC in the website which is given over here. Go to this link, apply this particular code, and the course which has to be given 12,000, you just have to give 3,799 for this particular code. Okay, so just spend this particular amount of money for the bright and awesome future which is going to come. Okay, so guys, I hope you are happy with the session. I hope you guys have understood. Don't worry at all. Then if you have understood, please don't forget to hit the like button, and if you think that the class was so useful, call your friends, let them also know such a class is happening, and bring them at the correct time to the JEE class, JEE Vedantu channel. Okay, and so that I'm telling you, just share this particular thing to all your friends, and don't ever forget to subscribe it. Yes, because the time is almost consuming us. Yes, so tell me, before me going, tell me how was the class? You guys understood the theory? I have explained at the beginning, the theory I have explained at the beginning. Hi Sujit. Don't end. So everyone is crying. What to do? Don't worry, next class when you come, we'll be doing more number of questions. Okay, I'll come up with maximum theory also. We'll try to include maximum number of questions also. Fine. Thank you so much, Rupesh, as you find the class was awesome. Tomorrow, yes, at the same time you can find we'll be having the class on current electricity. We'll be doing maximum number of questions. Fine. Thank you so much. Okay. So guys, I have to tell you bye this time, and take care, study a lot, and be there with me and be in touch with Vedantu. Okay, bye guys, till we meet next time.